Welcome back to the Big Dog Podcast, brought to you by our friends in Loxley, Alabama. As always, we're glad you could join us.
All right, Lisa, let's jump straight into the guts of it, the essential components of any rotary screw air compressor. Let's start with the air inlet, your gatekeeper. It's like the bouncer of the whole operation. You need just the right amount of air coming in, or things start to wobble. Too little air, for example. Your compressor's going to struggle. Too much? You're overpressurizing, and that's going to wreck your system.
And that's what makes it such a critical component. It's not just about letting air in, it's also managing oil flow, right? Because when air is compressed, the oil plays a dual role. It lubricates the system and helps manage heat. It's fascinating how interconnected all these elements are.
Exactly. I mean, I've seen facilities wrestle with this. One shop I visited had their inlet valve set wrong for weeks. Too much air coming in, and it ended up damaging some of their other equipment. The downtime alone was a nightmare.
Oh, I can imagine. And that's where an adjustable air inlet becomes such a game changer. Brands like Kaishin even go a step further with hydraulic inlet valves for high reliability needs, especially in contaminated environments, you know?
Right. And while folks might think this is just a minor component, it really sets the stage for everything else to run smoothly. Now, once that air makes it into the compressor, we've got to talk about what happens next, the air end. This is the heart of the machine.
The airend is where the magic happens, isn't it? Once air flows in, the interlocking helical rotors compress it. And here's the cool part. These rotors don't actually touch. That's what gives rotary screw compressors their longevity and reliability. No wear and tear on the rotors themselves.
And yeah, the oil-lubricated ones are doing a ton of heavy lifting here. It's not just about lubricating, like you said, it's sealing off airflow and removing heat. That oil's handling multiple jobs.
But not every application is going to be okay with oil mixing in, right? Take pharmaceuticals or food-grade applications. You don't want any possibility of contamination. That's where oil-free designs shine. Sure, they cost more upfront, but for sensitive industries, they're non-negotiable.
Oh, completely. It's interesting how the extra stage and two-stage compressors like Kaishan's doesn't just split the workload. It boosts efficiency and even gives you energy savings down the line. That's the kind of design thinking that minimizes operational headaches.
And it really underlines the importance of monitoring, air volume consistency, and how those components work together. If the air inlet and airend aren't perfectly in sync, you're looking at inefficiencies, wasted energy, and potential system wear.
Yeah, and all of it comes back to the fundamentals. Understanding these components and how they interact is key. Without that, you're pretty much flying blind. And honestly, who can afford that? Building on how those components work together, let's talk about what drives them, the motors. Honestly, motors are one of those things you can't afford to overlook. The horsepower is everything. It directly controls how much air you can compress. Bigger motor, higher capacity. But here's the kicker. Overspec a motor, and you're just burning through electricity you don't need. Waste of power and money.
Exactly. And it's not just about size. You've got primary and secondary motors, each doing their part. The secondary ones might be running cooling fans or oil pumps, and those are just as essential for the whole system to stay balanced. Plus, the design matters. A lot. The totally enclosed fan-cooled motors reduce the risk of debris getting in, right? Keeps everything running cleaner and longer.
For sure. Open motors? Forget it. They'll let contaminants in, and then you've got a whole new problem on your hands. And when we're talking about compressors used in extreme environments, like, say, manufacturing facilities that deal with a lot of dust or heat, that's where these added protections pay off big time.
Right, and the motors need the control panel to make sense of all the moving parts. That's the brains of the operation. From keeping an eye on pressure to temperature to voltage, it all shows up there. No more guessing games. And with IoT monitoring, Jason, the insights you get are next level.
Yeah, I mean, now you can pull data through the Internet of Things about your system status wherever you are. I heard of a plant where the system flagged a pressure drop remotely. Turns out one of the valves was starting to go. They jumped on it before it even became a failure. That's some next-gen troubleshooting right there.
Oh, absolutely. And it's not just convenience, it's safety. Look, these panels deal with multiple voltages. You don't want someone just popping them open without knowing what they're doing. It's why the remote access tools are such a game changer. Operators can monitor everything outside the cabinet and stay safe.
And speaking of safety, let's talk about monitoring systems. We're looking at sensors, transmitters, switches, valves, all keeping the whole system in check. I'm talking real-time tracking for things like pressure and temperature.
And if these systems aren't calibrated regularly, that's when things start to slip. A clogged filter here, a misaligned pressure reading there, it can spiral if you're not proactive. Think about minimum pressure valves, for example. They make sure the pressure leaving the compressor fits the system requirements. But if they're even slightly off, you could choke your whole operation.
Yeah, or worse, overpressurize and put your folks at risk. The key is keeping those sensors sharp. Maintenance, Lisa. Maintenance saves lives and machines.
Couldn't agree more. It's all interconnected. Motors, the control panel, the monitoring systems. Overlook even one element, and you're gambling with the entire performance. It's about keeping every part in harmony.
And that's where the risk lies, letting even a small issue snowball. Spot it, fix it early, and you save yourself a ton of headaches later on. And that's exactly why everything we've talked about, motors, control panels, and sensors, ties into one crucial aspect: thermal management. If you let heat go unchecked, it's not just a performance issue, you're inviting a system-wide failure waiting to happen.
Absolutely. So, let's start with the air-oil separator. It's a key player in ensuring air quality, especially for industries that can't afford any contamination, like electronics or food processing. It removes nearly all the oil from the compressed air.
Right. And I've seen firsthand what happens when you let separators slack. There was this one facility I visited, had a separator that hadn't been replaced in years. Long story short, a ton of oil got into their air system, ruined a batch of products, and they had to recall everything. Major hit to their bottom line and reputation.
Oh, yikes. That's a costly lesson. And it's a reminder that preventive maintenance on these separators is non-negotiable. Keep the filters clear and change them on schedule to avoid those kinds of disasters.
Exactly. Plus, there's the oil cooler to think about. It manages the heat generated from compression. Heat that doesn't get handled? You're looking at overheating issues, damaged components, and let's not forget, way less efficient operation.
Right? It's all about keeping that oil within a safe temperature range. If it overheats, it loses its ability to do its jobs. Lubricating, sealing, cooling. It's like a chain reaction. And honestly, best practices like keeping an eye on oil cleanliness and swapping it out at the right intervals make a big difference in stopping those problems before they start.
Yeah, but oil isn't the only thing that needs cooling. The air cooler is just as critical. If you've got air running equipment downstream and it's overheating, you're in big trouble. I mean, tools break down, seals fail. You're setting yourself up for some serious downtime.
Absolutely. I'm thinking of a case where poor air cooling led to moisture problems in the system. The result? Corrosion and even ice forming in the lines during colder months. That's why air coolers really need to be oversized sometimes, especially in, say, oil-free systems where the compressed air gets even hotter.
Honestly, this is why the whole system has to be balanced. Every component, from the air-oil separator to the coolers, needs to pull its weight. Otherwise, you're just fighting fires instead of running a reliable operation.
And it goes back to monitoring, like we talked about earlier. If you've got systems tracking temperature and pressure at every stage, you can catch problems before they boil over, literally and figuratively.
Exactly. And that's the key takeaway here. Understanding these components and staying on top of maintenance doesn't just save money, it prevents a ton of unnecessary stress. Know your system, keep it running efficiently, and you'll thank yourself later.
All right, and that about wraps it up for today. This was such an important conversation. So many critical elements that go into making these compressors work at peak performance.
Yeah, no kidding. And honestly, you take care of these fundamentals and you're already ahead of the game. So keep that in mind, folks. Maintain those systems and they'll take care of you.
And on that note, thanks for joining us on the Big Dog Podcast. We'll see you next time.